He was supposed to take our ducks, but then he came over and he was like, I'm not taking them.
Oh my goodness.
Alright, bro.
Logarithms. Here we go. I'm gonna get through this as quickly and painlessly as possible. Yeah. Like this. Logarithms. So oh gosh, I dread these. Okay. Logs, if you remember this, it'll help you out. Logs are exponents. Okay? It's another way to write an exponential equation or an exponential expression, and the log always equals the exponent. So I think without further ado, I'll just show you what it looks like. Several of you have already said that you have a log button on your calculator, and you do, but it only works sometimes. And I'll have to tell you, I'm so sorry what that one time is. All right, here's what it looks like. Log base of A. All right. This is read log base B of A. Okay. This number is written as a subscript right down below, so be careful how you write it. And the A is written kind of on the same level as the log. Now, sometimes if this is missing, then it's a 10. And we'll talk about why that is. But it's a base 10. Actually, I'll tell you now why that is. We operate in a base 10 number system, right? We go 1, 2, 3, 4, 5, 6, 7, 8, 9. And at 10, it switches back to 0, right? And then we add another digit. And then it's, everybody knows that? You all know that or no? Doesn't matter to you. Okay. We operate in base 10. Logs are in base 10. If there's nothing there. So if I just wrote this, notice there's no log there. I mean, there's no base, which means there's an invisible 10 there for the base. Okay? Okay. Yes, I'm going to do several. So, like what it would look like. So maybe log base 2 of 5. Okay? Now, how are we going to use this? What are we going to do? So we can switch from what we call logarithmic form, which would be just written as a log, over to what we call exponential form, which means we write it as an exponent. And I'm going to show you exactly what that means and exactly how we do that. I'll give you a second to. You used to call me on the cell phone. Should have what? He wasn't old enough. He'll be able to go next year.
How was it? I didn't remember.
Okay. This is read as log base 3 of 9 equals 2. Okay. So if I change this form, this is in like we said, logarithmic form. I can change it over to exponential form. And to do that, I'm going to start with the base. What's the base? 3. Remember I told you in the beginning, logs are what? Exponents. So what the log equals is always the exponent. So 3 with an exponent of 2 must equal, and then you put the 9 that's left here. So that's exponential form. So you take the base, and this is a cool little trick, but it works if you have the log written first. You take the base, you raise it to this power, and it equals 9. It makes an E. 3 to the second power equals 9. Would y'all stop? So we're going to flip-flop between these two forms before we do anything else and see what happens and see if you can do it, okay? So let me give you one to try. Convert this over to exponential form. You see what we're doing? It is. That's exactly what it's doing. So in exponential form, what's the base? Raised to what exponent? Equals. Do another. I told you today would be easy, but no, that's not all we got to do. Change it to exponential form. That don't make sense? What you got? 7 to the 0. Rewrite that one and see if it makes sense to you. Everything makes sense? Right, because it's going to, so it's, yep, equals. Does it make sense does that work, in other words? Because what happens with a negative exponent? It flips it over. That's exactly right. Let's try some going the other way. Is that true or false? What's an exponent of 1/2 mean? Think sunshine. Sunshine. No, sunshine. Are y'all done? Why?
Because
Square root. 1/2 is a square root, right? Write it as a logarithm. Log, what's the base? 36 of 6 equals 1/2. It always equals the exponent. True or false? What? True. Write it as a logarithm. Log base what? 2 of equals. Remember, logs are exponents, so logs always equal exponents. All right. Yeah, Armando, why aren't you wearing it?
not all of you. Oh, yeah. I got my. You got a green card? It's in I was doing a green card. Yeah, you're right.
What do you think that equals? Without a calculator, without doing anything, what do you think that equals? 4 or 2, I heard. Say it again, Dixie. 3. Why does it equal 3? 2 to the third power is 8. We're looking for the exponent, right? You did. I got to get you a piece of candy. Hold on. Then put another one up here. What about that one? Oh my goodness!
Right? It is.
That is right. That is right. Armando, no lie.
What? No, I don't. I will. It'll be dependent. Alright, because the exponent and the exponent is -1. I didn't know you had them. Alright, let me go.
What'd you think I had?
Like,
Oh, that's nasty. I only have good candy. All right, so we said -1 because it's got to flip over. All right, you're going to have to earn this one. How hard should I make this first?
-2, 8. 31. -3, -7, -3,
Give somebody else a turn! But you are right, it is -3. Explain why, Armando. 3 times 3 times 3 and it's flipped over. Let's do another one. All right, this one's going to be hard. Two-thirds. Why is it 2/3? Oh, flip it. 3 halves. Why? The under 2 makes square root, right? Think about this. 9 to the 3/2 is the square root of 9 cubed. It's going to be 3 to the third power, which is 27. I told you that one. One more that's not quite as hard. Okay, let me do a little bit.
-5.
-5. Why? You gotta explain why.
I don't know, man. Because 5 can
And you gotta flip it for the negative. Y'all got to decide who gets it. I've only got one left. All right, so I hope you see kind of what we're doing here and how these are related to the exponent. Let's see. So you're looking for the exponent that would make it true. So if I asked you like log base 12 of 1, what do I need to raise 12 to in order to get 1? 0. Because the only way to get 1 is if it's 0. What?
You were looking at him when he did it.
What did it do? All right, let me show you a couple things really quick, and then I'm gonna set you loose. Sometimes things don't come out so nice and neat. What if I asked you for that one, what is the log equal to? Three to the fourth is 92. I can know that it's between 4 and 5, right? But I don't know exactly what it is. So your calculator will do this, but your calculator only operates in base 10. So I'm going to show you a little trick to use your calculator. I don't usually show you this on the first day, but you'll have some of these you'll need to do without a calculator, some you can use. So here's what you do. You can't. So what we do is we have to do what we call a change of base formula. And so I can rewrite any logarithm in the whole world. I can do the log of, and you do the number that's written the biggest divided by log of that little base. And this base can be anything you want it to be as long as it's the same thing top and bottom. And since your calculator operates in base 10, you could do the base 10 on top and bottom there. So here, this would be log base 10 of 92 divided by log base 10 of 3. And if you put that in your calculator, it will work and it'll give you the answer. Osmond, do you have it? Will you put it in there and see what you get? Log 92 divided by log 3. You see the log button? Should be between 4 and 5. 4 point what? That's good. So make sure you can put this on your calculator and you can get this back out, okay? And that works for any. Make sure you close it out. So hit the log button, close it, and then divide it by log of 3. Got it? And just to show you that it works and it always works, let's do an easy one. Log base 2 of 8, what should that equal? 2 to the what power is 8? 3. So take out your calculator and do log 8 divided by log 2 and make sure you get 3 there. Your hair looks good. Yeah. Not you. I'm not. 3. Okay. So that's what we call change of base. Okay, let me show you what I got for you.